can start, Shruti.
Good afternoon and a very warm welcome to all the participants for today's Tech Talk series, Civil Tech Talk series. I extend our heartiest welcome to Dr. Nitin Kumar Tripathi, Director Special Degree Programs, AIT Bangkok. Task, as you know, Telangana Academy for Skill and Knowledge is the government of Telangana's initiative to Facebook and YouTube Live also.
Yes. We can start, Shruti.
Good afternoon and a very warm welcome to all the participants for today's Tech Talk series, Civil Tech Talk series. I extend our heartiest welcome to Dr. Nitin Kumar Tripathi, Director Special Degree Programs, AIT Bangkok. Task, as you know, Telangana Academy for Skill and Knowledge is the government of Telangana's initiative to skill students. And a very warm welcome to all the participants for today's Tech Talk series, entrepreneurship and education. I extend our heartiest welcome we help bridge the industry and academia gap. Director Special Degree There are two areas that we mainly focus on. One is to reduce unemployment. As you know, Secondly, reduce underemployment and ensure that our students get the kind of job skills that they are trained and qualified for. Three main areas. As part of our initiatives, we have started Civil Tech Talks, which is a weekly technical series on practical civil engineering issues. And these issues will be addressed by experts from the industry and academia. The whole objective of this program is to help civil engineering students understand what are the practical on-field issues that you'll face once you start working in this beautiful field of engineering, and how you can prepare yourself for the industry while being in college. This is the sixth talk we are doing in the series, and I think we couldn't have done a talk on this particular topic at a more appropriate time than now. Last 1 week has been very difficult for Hyderabad. We've been have experiencing waves after waves of heavy downpours, and probably it's time for us to think, why are we facing these problems? Understanding what is sustainable development and focusing on ensuring that at least the future development will be sustainable is the only solution to avoid such problems in the future. On that note, I welcome everybody.
You are now muted. You are now unmuted. You are now muted. You are now unmuted.
Okay.
You are now muted.
क्या डैमेज देखने के लिए आए थे क्या? पूरा घर में पानी आ गया था, मैट्रेस से लेके पूरा पूरा हो गया। तो ये लोग हम लोग का लॉस नहीं हुआ जहाँ पे इनके मम्मी लोग रहते ना, वहाँ पे लॉस कितने वाले थे, इनके बहन के पास नहीं लॉस हुआ। क्या डैमेज देखने के लिए आए थे क्या? ले लेके हम लोग को पानी आ गया था, मैट्रेस से लेके पूरा पूरा हो गया। तो ये लोग हम लोग का लॉस नहीं हुआ जहाँ पे इनके मम्मी लोग रहते ना, वहाँ पे लॉस कितने वाले थे, इनके बहन के पास नहीं लॉस हुआ। गेट खोल दिया, इसकी वजह से पानी एकदम से आया, तो ऑप्शन भी नहीं था सेट करने के लिए।
You are now unmuted.
क्या डैमेज देखने के लिए आए थे? पासपोर्ट तक ले लेके पूरा पूरा हो गया। तो ये लोग हम लोग का लॉस नहीं हुआ जहाँ पे इनके मम्मी लोग रहते ना, वहाँ पे लॉस कितने वाले थे, इनके गेट खोल दिया, इसकी वजह से पानी एकदम से आया, तो ऑप्शन भी नहीं था सेट करने के लिए।
You are now unmuted.
क्या डैमेज देखने के लिए आए थे? पासपोर्ट तक ले लेके
You are currently the only person in this conference.
हम लोग का लॉस नहीं हुआ जहाँ पे इनके मम्मी लोग रहते ना, वहाँ पे लॉस कितने वाले थे, इनके गेट खोल दिया, इसकी वजह से पानी एकदम से आया, तो ऑप्शन भी नहीं था सेट करने के लिए।
You are now unmuted.
क्या डैमेज देखने के लिए आए थे? पासपोर्ट तक ले लेके
You are currently the only person in this conference.
हम लोग का लॉस नहीं हुआ जहाँ पे इनके मम्मी लोग रहते ना, वहाँ पे लॉस कितने वाले थे, इनके गेट खोल दिया, इसकी वजह से पानी एकदम से आया, तो ऑप्शन भी नहीं था सेट करने के लिए।
You are now unmuted.
क्या डैमेज देखने के लिए आए थे?
You are now muted. You are currently the only person in this conference.
हम लोग का लॉस नहीं हुआ जहाँ पे इनके मम्मी लोग रहते ना, वहाँ पे लॉस कितने वाले थे, इनके गेट खोल दिया, इसकी वजह से पानी एकदम से आया, तो ऑप्शन भी नहीं था सेट करने के लिए।
You are now unmuted.
क्या डैमेज देखने के लिए आए थे?
You are now muted. You are now unmuted. You are currently the only person in this conference.
हम लोग
You
का
are now
लॉस नहीं
muted.
हुआ जहाँ पे इनके मम्मी लोग रहते ना, वहाँ पे लॉस कितने वाले थे, इनके
You are now unmuted.
गेट खोल दिया, इसकी वजह से पानी एकदम से आया, तो ऑप्शन भी नहीं था सेट करने के लिए।
You are now unmuted.
क्या डैमेज देखने के लिए आए थे?
You are now muted. You are now unmuted. You are currently the only person. You are now muted.
हम लोग
You
का
are now
लॉस नहीं
muted.
हुआ जहाँ पे इनके मम्मी लोग हैं
You are now unmuted. You are now unmuted. You are now muted. You are now unmuted. You are currently the only person. You are now muted.
Okay, I've unmuted it.
You are
Can
now
you hear
muted.
me? Yeah.
You are now unmuted. You are now unmuted. You are now muted.
Hello.
You are now
Am I
unmuted.
audible?
You are currently the only person. You are now muted.
Okay, I've unmuted it.
You are
Can
now
you hear
muted.
me? Yeah.
You are now unmuted.
Okay, Sita. Oh no.
You are now unmuted. You are now muted.
Hello.
You are now
Am I
unmuted.
audible?
You are currently the only person. You are now muted.
Okay, I've unmuted it.
You are
Can
now
you hear
muted.
me? Yeah.
You are now unmuted.
Okay, Sita. Oh no.
You are now unmuted. You are now muted.
Hello.
You are now
Am I
unmuted.
audible?
You are currently the only person. You are now muted.
Okay, I've unmuted it.
You are
Can
now
you hear
muted.
me? Yeah.
You are now unmuted.
Okay, Sita. Oh no.
You are now unmuted. You are now muted.
Hello.
You are now
Am I
unmuted.
audible?
You are currently the only person. You are now muted.
Okay, I've unmuted it.
You are
Can
now
you hear
muted.
me? Yeah.
You are now unmuted.
Okay, Sita. Oh no.
You are now unmuted. You are now muted.
Hello.
You are now
Am I
unmuted.
audible?
You are now muted.
Hello.
You are now
Am I
unmuted.
audible?
You are now muted.
Hello.
You are now
Am I
unmuted.
audible?
You are now muted.
Hello.
You are now
Am I
unmuted.
audible? Hello. Am I 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 audible? Sir, can you hear me?
Yeah.
Sir, అదే మీరు లింక్ ఇచ్చారు కదా.
Ah.
That if I use that link, it is opening up a few websites. It's not opening up a PDF document.
Oh.
Sir, can you hear me?
Yeah.
Sir, I
can
did
you
link
modify that?
ఇచ్చారు
You
కదా.
can edit that link, kada?
That
Okay.
if I use that
You
link,
can,
it is opening up a few
reset
websites.
the link.
It's not opening up a PDF document.
In your system. Oh.
Sir, can you hear me? Okay,
Yeah.
I'll just share my
Can you
screen, sir.
modify that?
Sir.
You can edit that
Can,
link, kada?
can you see my screen now?
Okay.
If I use that
You
link,
can,
it is opening up a few
reset
websites.
the link.
It's not opening up a PDF document.
In your system. Oh.
Sir, can you hear me? Okay,
Yeah.
I'll just share.
Can
This
you
was the link
modify
that you
You
gave,
can
sir.
edit that
Can,
link, kada?
can you see my screen now?
This
Okay.
file.
If I use that
You
link,
can,
yeah, the one that is there in
reset
this
the link.
bar,
Yeah,
not opening up a
SP6.
PDF
No,
document.
no.
Can
Actually,
you hear me? Okay, I'll
this
just
is
share.
website.
This was the link that you
You
gave,
can
sir.
edit that
Can,
link.
can you see my screen
File
now?
I have
Okay.
smashed. I have uploaded to
Yeah,
you.
the one that is there in this bar, not
I have
opening
sent by mail. No. Actually,
Okay,
let me check.
I'll
This
just
is
share.
website.
The presentation.
And
Can you see my
file I
screen?
have smashed. I have uploaded to
Yeah,
you.
the one that is there in this bar, not
I have sent by mail. I sent this same file. I asked this. Yeah, this file I have
the
sent.
presentation.
PDF file. And file I sent by mail. 5 MB
Yeah,
file.
the one that is there in this bar,
I have sent
I
by
haven't,
mail. I sent this same file.
I got the
asked
presentation also.
file I have
The
sent. No,
presentation.
you have sent me the meeting link. I sent the
Yes.
mail on 5 MB
Yeah,
file.
the one that is there in this bar,
I haven't,
In that attachment is this same file.
I got the
asked
presentation also. The
No,
presentation.
you have sent me the meeting link. I sent the mail on 5 MB
Yeah,
file.
the one that is there in this bar,
I have
In that attachment is this same file.
I got the
Okay, this one.
presentation also. The
No,
presentation.
you have sent me the meeting
I'll
link.
upload
I
it.
sent the mail on 5 MB file.
This is the document, no, sir?
Yeah, that's right.
I have
In that attachment is this same file.
I got
Okay, this one.
presentation also. The
No, you have sent me the meeting
I'll
link.
upload
I
it.
sent the mail on 5 MB file.
This is the document, no, sir?
Yeah, that's right.
I have
In that attachment is same file.
Okay, this one.
Presentation also.
No, you have sent me the meeting
I'll
link.
upload
I
it.
sent the mail on 5 MB file.
This is the document, no, sir?
Yeah, that's right.
I have
In that attachment is same file.
Okay, this one.
Presentation also.
No, you have sent me the meeting
I'll
link.
upload
I
it.
sent the mail on 5 MB file.
This is the document, no, sir?
Yeah, that's right.
I have
In that attachment is same file.
Okay, this one.
No, you have sent me the meeting
I'll
link.
upload
I
it.
sent the mail on 5 MB file.
This is the document, no, sir?
Yeah, that's right.
I have
In that attachment is same file.
Okay, this one.
No, you have sent me the meeting
I'll
link.
upload
I
it.
sent the mail on 5
It's
MB
got 84 pages, sir.
Yeah, that's yeah.
I have
In that attachment is same file.
okay, this one.
You can just check whether it opens.
Yes,
Sorry, I'll check that.
it's uploading.
Yeah,
2 minutes.
I have okay, this one.
you can just check whether it opens.
Yes,
Sorry, I'll check that.
it's uploading.
Yeah,
2 minutes.
I have okay, this one.
you can just check whether it opens.
Yes,
Sorry, I'll check that.
it's uploading.
Yeah.
2 minutes.
Yeah,
Okay, this one.
you can just check whether it opens.
Sorry, I'll check that.
It's uploading.
Yeah.
2 minutes.
Yeah.
Okay, this one.
You can just check whether it opens.
Sorry, I'll check that.
Yeah.
The streaming seems to be on already. It's gone live. Okay, this one. Can we stop it and restore at 3 2?
Whether it opens.
Sorry, I'll check that. The streaming seems to be on already. It's gone live. Can we stop it and restore at 3 2?
Pradeep, please confirm, can we start?
You are now unmuted.
Pradeep, please confirm, can we start?
You are now unmuted.
Pradeep, please confirm, can we start?
You are now unmuted. You are now muted.
Good afternoon, and a very warm welcome to Civil Tech Talks 7.
You are now unmuted.
Before we start, I'd like to give a brief introduction about Telangana Academy for Skill and Knowledge. TASK is a not-for-profit organization established by the government, essentially to skill students and make them industry ready. We work on three main areas. One is employability, education, and entrepreneurship. The main objective of TASK is to help students skill themselves to the industry standards so that we can reduce unemployment as well as underemployment in our state. As part of these objectives, one of the things that we have started is the Civil Tech Talks, exploring the four standards so that we can reduce why Civil Tech Talks is because underemployment in our state. In our regular academics, there are a lot of issues from the practical standpoint that is the Civil Tech Talks, exploring the Civil Tech Talks, which is a weekly technical series in which every week we are going to address a different practical issue that we will face in the field from the practical standpoint in the Civil Tech Talks. Today, we have with us a very eminent tech personality, Shri Surya Prakash Garu. We are going to address a member of the Kasi family for 2-3 years now, because we are partners with Smart and Fresh. Surya Prakash Garu, he is also the MD of Mahabalipuram project and founder trustee of Smart and Fresh, an eminent engineer, consultant, and mentor who has made significant contribution to civil engineering. He started his journey in civil engineering with a bachelor's degree from JNT. He went on to do his MS in structures from IIT Madras, and after working as a design engineer for 5 years, he established Satyavani Projects and Consultants Private Limited in 1994. He also founded Smart Infrest and is the founder and mentor of this not-for-profit organization dedicated to civil engineering, to the field of civil engineering. It works with the objective of enhancing employability and employment in this field of engineering. He was the president of ACCEI from 2013 to 15 and is the founding president of PSI from 2013. He is also a part of several other organizations. He is an FIE, FACCE, MICI, and several more. Surya Prakash Garu is the member of expert committee appointed by the government of AP from June to October 2019 to review projects of irrigation, urban development, R&D, and others. He has also authored a book on design and implementation of communication towers. He is the guest training faculty to RECTI, SKI, CTI Hyderabad on CAD of transmission line towers. There's a lot to be said about Sir. He is the organizing secretary of WISE 2004. He organized workshops and on PepsiCon 2013, 14, 15, 17, 18, A3C 2010, MECCon 2007, EIA 2003, IS 456, New Vista, Seismic Design of Buildings, IS 1996, ISIS 1999. He was also a member of the Expert Committee for Categorization of Seismic Damaged Structures. Surya Prakash Garu participated in several international conferences, namely Como, Italy in 2011, SCWC in Seoul, South Korea, IASS 2012, and Precast in 2014 Moscow, and SCWC 2015 Singapore, SCWC 2019 in Istanbul, and several more. In addition to being a very strong pillar of the industry in the field of civil engineering, Surya Prakash Garu also has interests in the educational sector. He's guided projects for MTech and BTech students of civil engineering at IIT Madras, JNTU Hyderabad, and NIT Warangal. He is also involved in training engineers in several subjects. He is the chief resource person for LEAP lecture, in which 56 topics are covered as part of it. It's one of the Smart Infrest initiatives. Surya Prakash Garu handled several prestigious projects during in the past 3 decades. Some of the projects he undertook include affordable housing, buildings, residential, commercial, office, IT, industrial, hospitals, hotels. In terms of infrastructure, he's worked on road projects, bridges, metro rail, runways, hangars, logistic parks, leisure theme parks, stadiums, transmission lines, towers, FM, TV, microwave, and cellular towers, providing architecture, engineering, and project management services. Some of his prestigious clients include the Ministry of Defense, INFS, Tech Mahindra, GVK, GMR, BSNL, Idea, Airtel, Tata, Saket, Manjeera, Janapriya, Ashoka, etc. I think it's an amazing kind of contribution that you have made, sir, to the field of civil engineering. We're very happy to have you with us today. This series of Civil Tech Talks is being run in association with NIT Warangal and Smart Infrest themselves. So very happy to have you, sir. Welcome, and over to you for an educative session. Thank you so much.
Thank you, Shruti, and for a kind introduction. And good afternoon to all the participants of this talk today. Very important subject and evolving subject in India in the construction industry. The topic I chose specifically the design life of building structures, durability, planning, design, engineering, and construction aspects of this topic. So I'll be covering the topic that is not fully covered in our Indian standards. And when I'm trying to prepare for our talk today, I came to know that worldwide itself, this topic is still evolving, I would say. So I'll be covering I'm getting echo, Shruti. Is it okay now? Yeah.
Yes, sir, it's okay.
Yeah. So let me go on to the overview of my presentation today. So introduction to the topic and longevity and heritage structures that are there worldwide and in India particularly, and factors affecting service life design. That's a very important point actually. What are the factors we should understand before we go into the design life of any structure or buildings today particularly? Durability aspects which are covered in IS 456 and ISO design life methods, European Eurocode, Bureau of Indian Standards, and IRC provisions. I'll be covering partly actually. It is a very large subject, but I'll try to cover important aspects of all these points because it's a new area which is yet to be codified. These design life aspects of the structures. That means perfectly being able to design a particular given life of the structures by defining the specification and the structural systems and materials for achieving that lifespan of the structure. This is the challenge before us. So I'll be covering these aspects, and I also give a small case study of a project where we have worked out the specifications, what all to be covered. So in my talk today, I'll be covering these aspects. So we have 1 hour time, and I'll try to cover as much as possible in this time. So early 20th century, when the reinforced cement concrete is evolving, 1903 and all, where theory is still not fully developed, but still people started constructing buildings in reinforced concrete. Otherwise, we had the concrete before that, but reinforced concrete as a concept started evolving in 20th century, and people got excited with that concept of reinforcing the concrete because people found concrete as a strong material for compression, but weak in tension, as we all know. Once they got this idea of reinforcing this concrete, they thought that they can build structures which will live for 1,000 years perhaps. But in reality, we are seeing lifespan is only limited between 50 to 100 years if they are well maintained, and if they are not well maintained, even less than 50 years. And we are seeing many buildings collapsing even during construction without proper construction methods. So today I'll be covering these aspects of lifespan of these reinforced concrete structures. So what are the structural forms or forces that affect the life of structure? We have seen the oldest structures standing are pyramids, and we know that the pyramid is a structure, a natural structure where we have only down thrust, and there cannot be overturning in a pyramid, and they are very stable, and load dispersion is by natural means. The natural load dispersion happens, and that's why we have pyramids which are standing for 5,000 years. And we have stupas in India, temples, which also close to the pyramid, but they are taller and more slender compared to these Egypt pyramids. And we have seen, but the temple construction is so well defined. There is no eccentricity in the construction, and the dimensional stability and symmetry in the construction are all predefined, and they will do this construction religiously. That is why we see that in India also many structures. In fact, if you compare the worldwide structures and in India, India has got almost equal number of structures, heritage structures standing more than 1,000 years and more than 2,000 years. Next, coming to the present scenario, in the last 2 centuries or 3 centuries, if we see, we have evolved structural systems from arches, pure compression system, dome spatial structures, which are pure in compression because there was no concept of reinforcement. And now the latest, we have these very tall structures with shear walls and frame tubes kind of structural system, which can also handle flexure. The only challenge when we handle flexure is the handling the crack width in the tension zone actually, and also the shear. So this is the challenge with which we have to discuss today, how to design the long life for these structural forms and the forces that we are estimating. The other forces, as we move forward, as we are advancing, we are also tackling torsion, we are also tackling tension, we have tensile structures, and we are also tackling overturning movement by anchorages. We have further advanced to pre-stress and post-tensioning, and we are also handling the vibration loads from the static loads to vibration loads and impact loads. So this is the challenge before the engineers, considering all these kind of forces, all these kind of materials and structural systems. We should be able to still design a life for the structure. The loads that we deal with are self-weight, imposed dead loads. We have the live loads, moving loads. We have wind loads like earthquake. And the challenge when we design for a life, long-standing life, is the return period of these loads. And we are seeing fast changing the loads, wind loads or rain or earthquake. The frequency of occurrence of these incidents of highest wind load, highest seismic loads is changing very fast. We have seen, we had revision of IS 1893 for seismic in 2002, and now we have in 2016 revised with the provisions. So accounting for, imagine a structure which is designed some 30 years back, it has to be retrofitted. Without retrofitting, how anybody can ensure the life of that structure? So, and also the current scenario, the return period of these 100 years peak wind loads or seismic or rainfall, we have to consider. So the question of reliability comes into picture in the design. and all, and fire. Fire is another incident that can affect largely the life of a structure, though it comes as an accident. But fire is an accident, but still, if we are designing life, we have to cater to these accidents. And fatigue in the reversal of the stresses due to wind or any moving roads also has to be factored in when we talk about the life of the structure. Next is the soil settlements. We have to take into account the allowable settlements that we consider while calculating the safe bearing capacity, the creep and shrinkage of the concrete, because we are talking about concrete structures, life of concrete structures, the effects of creep and the shrinkage also has to be accounted for while we are designing the life of the structure. And a major problem that we are seeing nowadays in most of the buildings is the embedded conduits in the structural elements, whether it is columns, beams, slabs. We have electrical plumbing line being embedded, and they collecting the water into these conduits, and the leakage of these joints also largely. So this has to be also thought about when we talk about the design life of the structure. And lack of weatherproofing, because we have seen the effect of temperature. So to tackle the effect of temperature, we have to weatherproof the buildings actually. Primarily terrace, which is exposed, and also the facade, walls or structural elements that are exposed on the sides. Next important is the soil contamination, and we have to check the level of contamination or possible contamination that can happen during the life of structure. And earth pressure, in case of deep basements and all being constructed nowadays, we have to also take care of the earth pressure, variations in the earth pressure, and overburden pressures on the side earth pressure on the retaining walls, because the life of structure is also dependent on these aspects of containing the dampness entering into design. And the pyramids, this pyramid is 2660. This is even before the popular Egypt pyramids. And this you can see in a stepper form. And pyramid is a natural structure actually. It forms, even if you leave the sand, it forms in the form of a pyramid. So pyramids are natural structures, and there the advantage is very stable, highly stable, and you cannot move it. There are no flexural stresses in this kind of structures. Purely the load is transferred by dispersion, natural dispersion, and angle of repose or internal friction. The load transfer happens to the base, and so it could sustain. So let us examine what are all the factors that could give long life to these structures. Next is the Mohenjo-daro, the Indus civilization, 2600. There also they have used the bricks and the stone in the construction. Unfortunately, because of they are buried due to earthquakes or river floods and all, they have excavated and found this great civilization, which is more than 4,600 years now. So this is the structure which could withstand. So we can say that masonry structures can also withstand. You can see it is a swimming pool which was constructed kind of thing. These are the pyramids of Giza, Egypt, very popular, and there they have gone multiple pyramids, and they have also sustained, because ancient world they have built with the stones, and it is highly unimaginable those days how they could form such a perfect shape of a pyramid. But still, the life of this pyramid is achieved because of its stability in the forces, and also the material, the stone that is used in the pyramid construction. And this is another palace in Greece, which is in the period of 2000 to 1300 BC. It was also known large civilization with 100,000 people those days in the Greece. We are not interested in sociology of it, but you can see the structure. They have used the columns and the beam kind of structure and the plinth wall masonry with the stone masonry. So this is what we are trying to study. What are the longest standing structures? And in Italy, 600 BC, and it was a major Greek city. And here also you can see the columns, the stone columns and the beams kind of structure. And the large halls were theaters were constructed that time itself. And we have Ajanta caves. The caves also have withstood more than 2,000 years. You can see they have cut the natural hills to form the habitable places, and they also sustain. So this is another structure. And we have France, almost 2,000 years old. It is a structure. It was a temple constructed originally, and you can see the columns, beams, and a triangular shape, which is like an arch for the transfer of the load. And this also talks about the stability of the structure. And next, Colosseum, Roman Colosseum, 3-storied, again, almost like 2,000 years old. You can see this is also standing and mostly in stone masonry. And some of the concretes. I'm not showing all the structures. I've just chosen some of the typical things that have withstood, that have sustained. So to understand what material they have used and what structural system they have adopted and how they could sustain so many thousand years. And now let us look at the oldest structure in India. That is the Sanchi Stupa in Madhya Pradesh. The oldest stone structure, it is near Bhopal, and it is also UNESCO heritage structure. So this is the structure. You can see the stupa. It's like a dome and wall kind of construction, which is constructed more than 2,000 years. And this is the dome again. And this is a beautiful construction that happened more than 2,000 years. And it is a Buddhist stupa in India. Next is the Shore Temple in Mahabalipuram. This is also single stone rock cut Shore Temple, which is constructed in 7th century, 8th century kind of period, and is still standing. And we also have so many other temples like Madurai and all, but I'm showing some of the interesting Khajuraho temple. This is also constructed more than 1,000 years back. And we have Telika temple, and it is near Gwalior Fort in Madhya Pradesh again. And this is also standing, longest standing, more than 1,000 years old. And next we have this Hawa Mahal in Jaipur, which is also in nice Agra stone, sandstone construction, which is standing more than 400 years. Now let us come to RCC buildings, serving life more than 100 years. So what are the structures? So the oldest high-rise structure that is standing in the world is Ingalls Building in Cincinnati, Ohio State. So it is constructed in 1903. This is a 16-story building in reinforced cement concrete. When the theory of reinforced concrete is still not developed fully, and the stress theory and all that, but still they have constructed, and it is longest standing. So if you want to think of reinforced concrete building, which is living for more than 100 years, this is the best example which we have. And they have done the reinforcement in a different way. What we detail now is not the method they have followed. And it was, I would say, I will use the word crude way of reinforcing the concrete they have adopted, but still it is standing more than 115 years life. So this is the first RCC high-rise building with the column sizes of 750 mm or 30 inches kind of thing. And the amount of concrete produced during construction those days was 76 cubic meters in 10-hour shift. So that is the, now we are able to produce in 1 hour this kind of concrete production. So, but definitely may not be of that quality. So this is Taj Mahal Palace Hotel in India, Mumbai. We have, this is also reinforced concrete and more than 100 years old, but not completely reinforced concrete. That is why it cannot compete with that Ingalls building, but still it has the reinforced concrete in this structure, and it is surviving, and it is a very most famous popular hotel in Mumbai. So now let us look at what is service life design. Service life design in India, what are the codes that we have, Indian codes, and what are the factors affecting climate change. That's the challenge for engineers to predict what is going to be the climate condition after 20 years. It could be better, it could be worse, because IPCC is working on improving the climate change, but still we have to keep our fingers crossed to see to what extent we are going to damage our environment or improve our environment, or bring back to the original state 50 years back kind of thing. And the probability is the biggest thing in estimating the life of structure. So we have to estimate the deterioration in the quality of concrete, deterioration in the reinforcement, corrosion by corrosion, and materials that we are using, whether it is aggregates, fine aggregates, coarse aggregates, or cementitious materials, and technology that we are using for construction. That is very important, because the quality of concrete depends on the method of mixing, method of transporting, method of placing, method of compacting, method of curing, all these steps. That is the most important vital element in talking about design life of the structure or service life design. And maintenance, even if we do the best of the structures, if they are not maintained, if they are not verified, monitored from time to time, and qualify for the revised loadings that are happening, it is going to be a challenge to sustain the service life design of the structure. So these are all the important aspects when we talk about the service life design of the structures. So normally, lifespan of structures, many people ask, what is the life of this building? So as an engineer, we should be able to say, but unfortunately, the present code, IS 456, based on which we design this reinforced cement concrete building, doesn't give guarantee for any life. It is only prescriptive. Whatever durability aspects that are covered in IS 456 is only prescriptive, not even predictive. The other things are predictive actually. So the life of a structure, normally if we follow all the standards, the quality standards of the concrete, quality standards of the material, and design standards, everything if we follow, a normal RCC building, a guaranteed life can be 50 years. And the bridges, as per IRC that we are designing, reinforced concrete bridges or pre-stressed concrete bridges, the life is 100 years, and the steel bridges 100 to 120. And if we are designing skyscrapers, so tall buildings or high-rise building, we have to design for 100 years life minimum, because of the cost that, and dams 80 to 100 years, flexible pavements, it is 8 to 10 years, and rigid pavements, that is a white topping, is supposed to be 30 to 35 years, all subject to proper design, proper construction, and proper maintenance as per the standards. When you do that, these are the life. So I thought that I must, because many students are also there, I thought that they should know what is the design life of the structure. Though I cannot sign any document that, okay, this building will be there for 50 years, because these are all only prescriptive. I can only qualify and say, subject to maintenance, subject to qualification, subject to periodic stability checks of the structure, I'll certify that this building will be there for 50 years. So this is the position today. And fortunately, the Bureau of Indian Standards is revising IS 456 to incorporate the service life design of the structures. So the design life or design service life or service life design of a building or other structure or components is the period of use as intended by the designer, after which it may need to be replaced, or before this period has lapsed, it should remain fit for purpose. Fit for purpose. That means if I have designed a residential apartment, people should be able to live in that apartment without the leakages, without the cracks, without the unsafe feeling in the structure. So the design life will vary according to the type and use of the element being considered, the Eurocode basis of structural design. And it gives indicative design lives. Eurocode also gives the indicative design lives, not the guaranteed design life of various types of structure, same as almost similar to Indian code we use in the bridges is 10 to 25 years, and category 3 similar buildings 15 to 30 years, and building structures and other common structures is 50 years, and monumental buildings, that is high rise, and bridges and infrastructure, main important infrastructure projects is 100 years. So this is the life of structure. The factors affecting design life. The design life may be affected by environmental factors such as moisture, humidity, and rain. So these are considered in our IS 456 at present in the exposure conditions. So mild exposure, severe exposure, extreme exposure, and all. And next is the wind, the kind of wind loads, the frequency of occurrence of these wind loads, and then temperature, the expansion joints or contraction joint that we provide in the structures also will affect the life of structure, the treatment of these expansion joints. And the pollution, air pollution, the quality of air, the pollution in the water that is there in the subsoil, the pollution in the soil. So all these factors, and the next important factor that affects is solar radiation. All these we are not considering in the design, but considering the grade of this pollution or grade of solar radiation, we have the provisions for providing cover or quality of material that we will be deciding based on these factors, and so that we will extend the life of the structure. It may also be affected by considerations such as maintenance practices, intensity of use, and other factors. So this is the thing that affects the design life. Who guarantees design life of a structure? Is it the engineer? Is it the builder? Or is it the contractor? Or is it the user? Who should guarantee? In fact, it is a combination of all. There is no legally agreed definition of design life. In fact, there is not even a legally agreed definition of design. So if it is to be included in contract documentation as a performance requirement, that is performance guarantee, we have to incorporate in the contract. So it is important that it is carefully defined within the contract document and that it is consistent with all other requirements of the contract documents. So in the contract, if we say that this structure has to live for 100 years, so as designers, as planners, we have to define the specifications, construction methods that will ensure the life of structure. And apart from that, we must put the conditions in the contract such that the documentation of the quality is maintained as envisaged in the design life. And then post completion of construction, during the handing over, the life of structure can be ensured by proper maintenance, periodic checks, and monitoring of the structure only. So there are many other definitions for quantifying the life of buildings or structures and their components, including required life. What is the required life of a structure? Let us talk about it. Suppose an independent house where we live. We are seeing technology is changing so fast, and the appliances are changing, automation is changing. So what is the minimum required life of the structure? And what is the cost of structure versus other things? Is it viable to design a structure like if I spend 800 rupees per square feet for the structure, is it worthwhile spending another 400 rupees to give life of structure to extend the life of structure to 100 years? Is it worth? So what is the required life that we have to define? What is the technical life of structure? That is serviceability requirement. We have limit of serviceability. Functional life again is linked to serviceability, but the serviceability, the limit state of serviceability is only the design. But when it comes to functional, there should not be rainwater dripping, there should not be sunlight directly coming into the building. That means roof has to be intact. So flooring has to be proper level. There should be slope in the flooring so that the dampness, water will flow. All this maintainability, that is the functional life. What is the economic life of the structure? So that also we have to define. And what is the finally service life? Service life is from the day we hand over the structure to the user to the day we decide to dismantle the structure. That is the service life. So today we are talking about service life. Our talk today is focusing on service life, not other things. Other lives are all economic life. Finance people will talk about functional life. The marketing people will talk about technical life. Structural designer will talk about, and required life. The end user who doesn't know what is the required life also, they will talk about it. But that will be always less. So what is the life cycle of a structure or a building? So we start with the design and planning, and we plan the specifications, material, concrete grade, and mix of the concrete and all that we decide, and the construction method and structural system is all decided at this stage. And then we go for the construction after appointing the contractor. Then the possibility of ingress of harmful agents can start here. So this is where your life gets affected. So your construction quality, the construction management has to ensure that there are no harmful agents. What are the possible harmful agents? In the sand, you can have chemicals. In the water, you can have chemicals. And you may not have compact properly so that from the air also it can enter. And so the construction period also we have to maintain and keep the standards for maintaining the life of the structure. Next is the occupied and in use. During this period, initially they will occupy once they feel it is all fine and there is no sign of deterioration. That is the perfect life. It is about 10 years, we can say. Then there will be initiation of deterioration. That means in our limit state, we allow cracking, and through the cracks or through the porosity of the concrete or through the honeycombs that are left without treatment, without protective coat, there will be harmful agents attaining threshold limit in the structure. Then propagation of deterioration, and then crack formation, which is physically visible. Otherwise also there will be cracks in the concrete. And then increase in ingress rate and increase in deterioration and then failure. So this is the life we are talking about. So from design, construction to failure, what is the life we can give? This is what we are talking about, 50 years. That should be the minimum. So how to ensure that 50 years is the thing to minimize this ingress of harmful agents during deterioration. So periodic inspections will help checking this deterioration. Once you can arrest this initiation of deterioration, then propagation can be contained. Once propagation is contained, crack formation is contained. And so this is the understanding of life cycle of the construction. So what is the service life design? So this we always say that it is probabilistic. We cannot define, I will design this building for 55 years. Not easy. I'll design this building for 96 years. It is as good as predicting human life. Nobody predicted pandemic. And now we are seeing how uncertain life is. And similarly, the structures also, the uncertainty, like in earthquake, is one of the biggest uncertainties. Cyclones we are seeing, like now in the last 20 years, we have seen in Hyderabad city 7 incidents of highest rainfall, which is higher than 100 years rainfall by 20% in 20 years. In 100 years, if there are 3 incidents of peak rainfall, in the 20 years, there are 7 incidents of peak rainfall. The peak is 20% higher than the peak of 100 years. So 10 times frequency increased, 20% intensity increased. So you can see the change of climate. That is because of the number of cyclones that are happening. So the wind incidence also is increasing. The rainfall incidence is increasing. It has many effects. We have seen many buildings, walls collapsing due to these rains. So degradation of performance and deterioration of different components of RC structures increase with age of the structure. That we all know. This deterioration of reinforced component depends on several parameters. However, modeling service life of RC structure by considering all the parameters is a difficult job. We can only, as I said, give prescription like periodic maintenance, periodic monitoring, periodic design check, periodic testing, like health checkup that we do for our human body. Same way, we have to do the health checkup of the buildings also. Every 5 years is a prescriptive thing. And every year, pre-monsoon, you check the structure for drainage, for flooding, for dampness, and all these factors. So this is very important. So the service life design is considering all these aspects. Only we can give the design life for the structure. So here we can see this is the, if we have a 50 years of life, maybe about 20 years you don't see any much problems if all is done well. But after 20 years, you have to check once for the onset of corrosion in the rebars. So we have these non-destructive testing methods. I have seen many buildings which are dismantled within 20 years also. We have seen the dismantled structure, we have seen the corroded reinforcement, and the concrete quality being also very bad. Concrete also has deterioration, and the cracking starts once the onset of corrosion happens, and the spalling, delamination of the cover portion we see within 30 to 40 years, and the structural failure happens after that. So to extend this life, we have to start monitoring from this stage itself. So if you have every 5 years maintenance for the structures, so we have to tell all the apartment owners, all the building owners, all the building maintenance people or facility management people to have the building health checkup and to have the pre-monsoon checkup of this building. So here, this is a diagrammatic thing. We have oxidation that happens to initiate corrosion in our crack. And then we have this onset of deterioration and the free rust. It opens up by the stage it comes here, and then it starts cracking. And then it will have the spalling and the full cracking at this stage, concrete level, cracking and concrete spalling, it will happen. So this is the stage where we are. Oh, it is better. Oh, sorry, I should use the full screen. I'm sorry. Yeah. So next is for service life design, the only document that we have readily available is 16204 ISO, which is formulated in 2012, as late as 2012. Before that, there was no document. So you can do the service life design based on this, and specifies principles and recommends procedures for verification of durability of concrete structure subject to known or foreseen environmental actions causing material deterioration, ultimately leading to failure of performance. And material deterioration without aggressiveness from the external environment of the structure, termed as self-aging. The inclusion of chlorides in the concrete mix might cause deterioration over time without the ingress of additional chlorides from the environment even. So It is further required that the designer shall communicate a maintenance plan. As I mentioned, without maintenance, no designer can give the life of a structure guarantee. So maintenance plan is the very important thing to the organization that manage the structure. This plan shall give the instructions on those activities that have been assumed during the design. As I mentioned, the protective coatings for the concrete, the cover portion that we consider, and any cracks due to external aggressive environmental factors that are not considered in the design, and or even if they are considered, because the prediction of exact deterioration level due to these environmental factors is very difficult because of the construction quality. So unless we do the inspection and check periodically at all the critical points, it is not easy to extend the life of the structure. So activities like general cleaning, ensuring that the drainage system works, application of sealants at regular intervals, expansion joints particularly. Since the reliability level on which the verification of the design is based is chosen on the basis of possible consequences, if structure does not stand the relevant local standards, that is very important. ISO doesn't give guarantee across the globe for the design, because in India itself we have 6 climatic zones. We have northeast, we have north, we have south, we have the western coast and eastern coast. Different temperature, humidity, and rainfall, snowfall, all these factors we have to consider while designing the service life of the structure. So if the structure will be subject to frequent in-depth inspections by qualified personnel, deficiencies will be noticed a stitch in time in early stage, enabling strengthening repair of the structure. Severe consequence will then be avoided. If the structure, at the other hand, will not be subject to any inspection, like foundations, the possible consequences will be much more severe. So inspection as conformity evaluation by observation and judgment, accompanied as appropriate by measurement, testing, or gazing. This implies both gathering the information and the data from the structure as well as conformity evaluation against some requirements. Like ISO 16204 assumes that the designer communicate to the operator that level of inspection in the design is based on the inspection plan, will then comprise ISO FDIs. So what types of inspection are required? What components of structure are to be inspected? Frequency of the inspections, performance criteria. As I mentioned, I've been telling 5 years is the frequency minimum. And qualification also, structural stability evaluation, because codes are changing, climate is changing. We have to do the documentation of all these results and action in the event of non-conformity with the performance criteria. Like in Japan, post-Kobe earthquake, all the structures are retrofitted for vertical acceleration. In India, we have 3 codal provisions change. Tell me how many buildings would have been retrofitted as per the latest codal provisions to extend the life. So people cannot complain on the service life of the buildings unless we do the retrofitting based on the revised codal provisions. Even concrete, we are saying minimum grade of concrete now is M25 grade, but all the old structures that are constructed with the M15 grade. So we have to retrofit the concrete even, and the cover that is there also we have to retrofit based on the exposure conditions of the structure. I'll try to move it faster because of the time. I think we are running short of time because very important points are there as we move forward. I'll cover. So you can refer to this IS 16204, which is a very important document as far as service life design is concerned. So as I'm only covering the important aspects of these design parameters. I'll cover abstract of all these things in my last slide. So I'll not go into details of all this. Main thing is avoidance of deterioration requirements calibrated according to the requirements of international standard and also the local standards. Next is the what does talk about durability. Let us look at it. As I mentioned, it is only prescriptive. Nowhere in IS 456 it says that your life of structure is 50 years. but only from the reliability coefficient that we take in 875 or 1893 K1 factor, we can imagine that depending on the return period of the maximum life while we are calculating the probability coefficient K1, we can structure normal structures, and 100 years is the important structures. So the durability criteria of IS 456 is all talking about concrete cover and the chloride penetrations and cement consumption, minimum cement consumption that is prescribed depending on the exposure conditions. So these are all the durability provisions. So materials, the cement content and water cement ratio of the concrete, workmanship to obtain full compaction and efficient curing, and the shape and size of the members, that is column size minimum, beam size minimum, slab thickness minimum, minimum cover provisions, and workmanship design detailing should be considered as per the codal provisions. And shape and size of the member, exposure conditions, the general environment exposure conditions are defined like mild, moderate, severe, very severe, and extreme. And the cover, that is minimum cover to any of the structural elements, is 20 mm, and increased in 5 mm for each of the condition, higher condition. And the nominal maximum size of entrained air, that is the porosity, is another important thing, and pH value of the water that we use in the concrete also has to be maintained between 6 to 9, and exposure to sulfate attack and exposure conditions. So what are the exposure conditions? Concrete surface is protected against weather or aggressive conditions. So the good thing is to have the protective coating to exposed concrete and foundations which are exposed to soil, particularly in the coastal areas. And concrete surfaces sheltered from severe rain or freezing, while wet concrete exposed to condensation, drain concrete continuously underwater concrete in contact or buried under non-aggressive soil, groundwater concrete surfaces. So these are all the requirements, and based on this, the requirements of cover are defined based on these exposure conditions. So you are all very well aware of this. So what are all the most severe conditions? Concrete completely immersed in seawater, concrete exposed to coastal environment, and concrete surfaces exposed to seawater, spray corrosive fumes or severe freezing conditions while it is wet, and concrete in contact with buried under aggressive subsoil groundwater, surface of members in tidal zone, and members in direct contact with liquid, solid, aggressive chemicals, factories. This is in factories, this will happen. And abrasive, like specialist literature may be referred for durability of abrasive structures. That means vehicular traffic and all that. And requirements of concrete and industrial floors exposed to abrasive action, for example, in case of machinery, metal tires and all that. Freezing and thawing in the low temperature, lower than M50 grade is used under these conditions. The mean total air content by volume of the fresh concrete at the time of delivery into the construction should be 0.2. And the free water cement ratio has to be maintained minimum at 0.35 to 0.4 kind of level, and aggregate size and shape of the aggregates, and then the cement content to be limited to maximum cement consumption and minimum cement consumption, and alkali silica reactions. So these are the table that has given the groundwater and then sulfates and chlorides, and minimum cement content and maximum water cement ratio. So these are the levels. Water cement ratio is no more a challenge nowadays because we are able to contain this in the mixed design by considering the plasticizers and super plasticizers and flow mix kind of thing. So these are the notes given to the table where chloride is encountered along the sulfates along with sulfates in soil or groundwater, OPC with calcium, aluminum content from 5 to 8 should be used. So for severe conditions such as thin sections under hydrostatic pressure, one side only a section is partly immersed, considerations have to be considered. So these are all the provisions of IS 456 durability criteria for taking care of chlorides and sulfates in the concrete, and alkali aggregate reaction. So these are all the things we should understand while doing the mix design of the concrete. So finally, the minimum cement content for plain concrete and reinforced concrete, we should follow these provisions. And this is for the sake of students I'm showing, because we should be clear and be aware of what are these durability provisions of existing code, which is going to be revised very soon. But these are all prescriptive only. By following this, you cannot give guarantee that structure will be safe for 50 years. So it is subject to all the maintenance and other considerations. Next important document that in India we have is IRC Special Publication 60, in which all the bridges that we design are designed for a service life design of 100 years. But even these provisions are prescriptive and predictive only. We can only predict that yes, this structure will stay for 100 years subject to these conditions. So it is all qualified statement about the life of structure. I'll skip going into this document. You can refer to this. This is available online. I'm not opening this document, but it gives when you do the maintenance, you will bring back the original position of the structure and again extend the life. Again, you do the maintenance and bring back the original condition of the structure. That's how you have to give the 100 years. You cannot give guarantee unless you have at least 3-4 periodic checks and rehabilitation or restoration of the original condition or design condition of the structure. So now I'm talking about, in fact, this is a practical challenge that I had to face. One of the client asked me to design the building for 150 years life. So I was searching everywhere. I could not find a solution to definitely design a structure for 150 years life. So then I started working on all the specifications, how I can ensure 150 years life. So the first and foremost is aggregates. The aggregates have to be non-reactive. So test for non-reactive aggregates. That means they have to be inert as much as possible, preferably granite. And then they should be well graded. Next is the cement. It has to be sulfate resistant, preferably pozzolanic, and fly ash to be increased, and content can be increased minimum by 10% from the design requirements. Water cement ratio maintain between 0.25 to 0.4, and water quality pH value try to maintain, though it code allows you to 6 to 9, better maintain pH value of 7, around 7, and then minimize the chemical content in the water quality. And the concrete, go for high performance concrete, and I will talk about this in the next slides. And admixtures compatibility with the cement, that is very important. We should test whatever cementitious material that we are using in the concrete, they have to be compatible. Admixtures that we are using, whether it is a plasticizer, retarder, or a flow mix admixture. And the concrete, you have to maintain the porosity between 0.1 to 0.2%. And we have to do the RCPT test and maintain the resistivity value for minimizing this ingress of the contaminants. Life of structure, the crystalline integral admixture. This will help the admixture that we have, crystalline compound, integral compound, that will help in reducing the porosity and use the protective coatings like membranes for the concrete. Never expose the concrete to the weather or soil. So have the membrane protective coatings for the foundations and facade structures. Corrosion, cover to be more for reducing the risk. So we have specified minimum cover 30, 35, 50 and 65 mm exterior covers. And reinforcement, either use stainless steel or treated or coated bars. Treated and coated bars. That means you can protect the reinforcement by doing the perfect, but not at the site. I have seen anti-corrosive coatings on the site, which is only an eye wash. It has to be a factory coated treatment. That means you have to do the cutting and bending in the factory, and after cutting and bending, you do the coating, or you can even go for galvanizing. And formwork to be engineered formwork, because formwork is the biggest culprit in construction. So if the formwork is not proper, you will have the honeycombs and all in the concrete, which cannot even be thought of. We are talking about porosity, how you can allow honeycomb at all. So the compaction of concrete by self-compacting admixture and testing of core samples to be mandatory. Core samples are not only cubes. I'm saying we have to do the core samples after construction to ensure that the porosity levels are maintained and the quality of concrete is also maintained uniformly. And quality assurance control and audit plan and maintenance of building to be based on standard practice and seismic qualification every 5 years to be mandated. And draft IS 456 provides guidelines for designing structure. It may be used to design for it had to come out. Actually, it is still in the development stage, but we are going to get IS 456 revision for the life. And 150-year return period for wind for calculating K1. That means we have to take the probability reliability factor to estimate the probability of the peak wind occurring during the 150 years of the life. Next is the high performance concrete. It's recommended to use high performance concrete for 150 years, because even for our infrastructure projects like metro or bridges, we use high performance concrete for 100 years itself. If it is 150 years, we have to have the high performance concrete, and preferably compressive strength, not for the sake of strength, but if you go for higher strength, the porosity will be reduced. Reduced porosity will help in reducing the attack of the chemicals on the initiation of deterioration by corrosion. And high performance concrete is quite brittle, but the introduction of fibers can improve ductility, and high durability of the concrete has to be ensured. And water binder ratio, again the same, and reduced flocculation of cement grains, wide range of grain sizes, densified cement paste, low bleeding and plastic shrinkage, less capillary porosity is achieved using low water to cementitious material that produces dense microstructure. Hence, migration of aggressive elements would be difficult. And high performance concrete discontinuous pores. This is very important. This is the design mix criteria, and stronger transition zones at the interface between cement paste and aggregate, and low free lime content, and endogenous shrinkage, and powerful confinement of aggregates, little micro cracking, and smooth fracture surfaces, and low heat of hydration. These are all the parameters. And the cover to concrete for all elements to be for next higher exposure condition. Improving concrete mix design by using blended fines, which are non-reactive, fines to be non-reactive, blending. Admixtures such as self-compacting compound, crystalline porosity reducing agent, and testing to ensure porosity limits within increased cover, permeability, and protective coating to exposed concrete, membrane protection, and weatherproofing and waterproofing to be maintained for all the exposed. So materials, specifications, loads, structural system, and standards. These are the parameters we have to cover while doing the planning and design for the longer life. And the mechanization in construction, that means quality assurance should not be manual dependent, skill dependent. It should be mechanized. Material handling, rigid monolithic construction is the preferred thing for longer life. I advise actually. And the cycle time of construction also has to be maintained based on good construction practices. Precast also will come in handy because the quality of concrete can be controlled in a controlled environment. And construction methods, construction time, and materials, making of concrete, curing, inspection, and construction handing over with proper documents, and maintenance and periodic design qualification. So service life modeling and service life design are related. They both involve durability performance of structure over its design life. And predictive models need to be linked to code standards either implicitly by being incorporated into them or explicitly by being accepted as suitable models for design that link with the design code requirements. Practically, real progress will occur only with formulation and ratification of design codes and standards. So there is no available design code readily for internationally also. It is still in codification stage. That's what I'm trying to say. So we all have to, engineering community has to work to speed it up so that we'll be able to design. And codification of service life design. For life design, service life design categorizes approaches to service life as full probabilistic, partial factor design, deemed to satisfy and avoidance of deterioration. It is only we can reduce the deterioration so that the expected life can be achieved. But you cannot guarantee that this structure will stay. So it is still prescriptive and predictive. And we have these models, software like Duracrete and Life 365, which can be used to predict only. So the location, the life of structure is location specific. So every engineer working planning and designing and constructing has to work on that location, particular location parameters and the site measurable durability parameters. That is the environment quality, the soil type, the water use, and materials that are available. Specification for implementation during construction, and the approaches mentioned are not codified. Still, they are not codes actually. So it is still in the development stage internationally also. So we have the limit state method, like limit state criteria. Limit state itself is a probabilistic, as we all know, and a defined service life and deterioration models and compliance tests. This is very important during the life of the structure, maintenance and repair strategies, and the quality control systems. Only they can ensure the life of the structure, service life. So this is the avoidance of deterioration, partial safety factors that we use, and full probabilistic models, statistical parameters, and deemed to satisfy approach. So this is the only thing that will give the service life and supervision, inspection, and condition control during service life and maintenance of the structure. These are the important parameters to ensure the life of the structure. So operational basis for service life design adopted. This is again FIB model. Again, this will only come up with the formulae that are used for arriving at the cover, arriving at the porosity levels, and so this is the chloride percentages that is splash zone near the sea, and you can see 0.1% by weight by binder. Chloride concentration foreseen in concrete mix, and chloride diffusivity, and these are all the factors as per the European experience. So we don't have, even in Eurocode, a definitive design parameter for ensuring or guaranteeing the life of structure. So again, these are all prescriptive only. So chloride concentration and the aging factors also are calculated based on the exposure conditions. And finally, we calculate the cover that is required, nominal cover that is required to achieve these parameters only. So the structural system, finally, the design life and durability to be ensured, we must have symmetry in the structural system, concentric loads as much as possible, reduce the eccentricities, axial, predominantly axial force transfer, and less secondary effects, that means the non-linear effects, and linear within elastic range. The stresses you try to maintain within the linear range, and in foundations reduce the allowable settlements and stable water table to be maintained. How we can do? You can do the sheet piles and all, and inert soil. Try to make the soil inert, that is exposed to the structure, and cover rebar porosity of the concrete and crack width in the design. Try to minimize the crack width in the design. If you have to design flexure for flexure and stability. Protective coatings and wind and earthquake return period, live load considerations during the life of structure, because whatever live load we are considering is in the current condition. If you are talking about 150 years, you have to increase probably the partial factors, safety factors. No conduits embedded, because you can't predict what is happening inside if you have the electrical conduits or plumbing lines inside the structure. And the structure should be independent of services. You provide ducts in the planning if you really want a long life for the structure. Cementitious and aggregate materials quality and gradation. These are the important factors. So I hope I have covered as much as possible. I have opened the subject. It is really a lot of eye-opening for me also as an engineer. I have chosen this topic because I was asked by my client to design for 150 years, for which I am in a blank condition, actually. Very difficult to achieve because there are no codes. When there are no codes, you can't convince any approving authority without code that you give me certificate for the 150 years life. So this is a challenge before all the engineers, and we all have to work for it to achieve the objective of designing service life for the structures. So with this, I'll open the forum for any questions. If organizers could collect any questions or open the users to ask questions.
Thank you, sir. That was extensive. So much to ensure that a structure. Ultimately, the objective of design is to ensure that this building stands.
Yeah.
If we are not able to ensure durability, then what is the point of spending so much resources? We do have a few questions from the participants.
Okay.
One of the questions is, can you tell us about some of the latest admixtures that provide sustainability in building materials, sustainable building materials? I think that's what the person is asking. Some of the admixtures that can make building materials more sustainable, maybe.
Actually, the admixtures that at present we are using are plasticizers and super plasticizers, and we have to use these to reduce the water consumption, to improve the workability of the concrete. If you ask me about the sustainable admixtures, I am not competent to talk about it. It is a highly specialized subject.
Okay. Another question we have is, kindly tell us about the durability of mud structures.
Yeah, it's very less actually. Mud itself is not a long-standing material, and it's not resistant to water. Probably you have to add some chemicals to the mud, like Falgi bricks. You can use Falgi bricks where gypsum is there, but still this mud structure has to be protected from the dampness and all. Otherwise, it will simply melt the mud. So mud cannot be a sustainable material for a life more than 5 years, maybe.
Another question is, what is the main aspect about the old buildings that makes them so durable?
Buildings that are existing or of good quality, I would say. In fact, with the advent of improvements in the materials, like we have 53 grade cement and we have 550 grade steel or even higher grade of steel and all, but our design methods and construction methods have not proportionately increased. We are still using the same formwork, bully centering or steel plates and all that, and we still have the same small joints, small plates, MS plates of 2 feet by 3 feet kind of thing. So they are not commensurate with the material advancements that we have. So the construction methods also have to be advanced, and the skill levels commensurate with these developments in the material. Without that, whatever advancements we have are not sustainable. We had old buildings with OPC, ordinary Portland cement, and steel, mild steel only, and design was based on working stress. Probably working stress doesn't allow cracking or limit the cracking, so that's why they are more durable. And now in limit state, we are allowing cracking, more cracking, and cracking is very enemy to life of structure actually. So we should minimize the cracking, or we should protect the surface against ingress of these contaminants to the concrete or steel.
Okay. Next question, sir. Is it advisable to use crushed rock instead of sand as the fine aggregate?
Yeah, very much. I am an advocate of machine crushed sand. For last 20 years, I have been using. In fact, nowhere code talks about sand actually. It is fine aggregate.
Fine aggregate. Yes.
Fine aggregate, if you follow the gradation as per IS 456, any material is okay. It need not form naturally from the river only. So please never insist on river sand in any of the projects, and we should use the fine aggregate.
Okay, sir. The next question is, can high strength reinforcement like Fe 550 and 600 advisable for in terms of durability?
It is advisable, but the corresponding cover, because cover is important. Cover helps in protecting the reinforcement, number one. Number two, also it is responsible for developing the bond stress. So if you are using high strength bars, you need to develop more bond. So you have to increase the cover or ignore the cover portion while calculating the development length for the development of the stress. If you don't provide adequate development length for bond and development length, then there is no point in using high strength bars. So we have to be very cautious in deciding the cover and calculating the bond length for high strength bars.
Okay. So I think we're almost at the end of the session. Just before we end, what would be your advice to all the budding civil engineers, sir, especially the ones in their final year and pre-final years? How do you think they can bridge the gap and make themselves attractive to the industry even before they graduate?
Yeah, my only point is they have to be academically good. They should have good knowledge of the subject, all the subjects, no exception actually. Whether don't say that I am a concrete expert at the student level. At the student level, you have to have all the subjects, whether it is water resources, fluid mechanics, soil mechanics, or engineering mechanics, structural design, materials, construction methods, contracts, all subjects you have to be complete actually. Please spend your time, remaining time at least, spend 8 to 10 hours in gaining the knowledge. In fact, for this lecture also, I had to spend 20 to 30 hours of study actually, with all my 30 years experience. Still, I am not satisfied. So it requires a lot of knowledge gaining. So if you want to be a good civil engineer, you must have all the subjects, and also every student must attend all the classes. This is another thing. Nowadays, whoever students I ask what is their attendance, they will proudly say 75%. I fail to understand how anybody can be absent to any class in the college. I don't remember being absent for any class during my undergraduate study. So that's very important. Attendance, labs, internships, and spending. When you are a student, you should spend 16 hours of your time for education only. Then you will not worry about your job or prospects of your career. Definitely you will be successful. This is my advice to the student.
Thank you so much, sir. We have just one more question has just come in. It's about same crushed rock. What are the criteria for selection of crushed rock finds as per design conditions?
Yeah, it has to be silica based, mainly whatever rock that we select for. Preferably, it should be silica based, granite kind of rocks, and sandstone, of course. And avoid limestone because it's a reactive material primarily. And use non-reactive stone. Igneous rocks also are okay, but you have to have the gradation perfectly, and the non-reactive material and the strength of the material also important.
Okay, sir. How can uh, uh, what are the precautions to be taken for buildings to withstand drastic climatic conditions?
Yeah, when you have the drastic climatic conditions, we have to have a design such that we have the enough protective coats for the structural elements, or protect the structure by using proper facade that will not allow the environmental factors affecting the structure. So, like we wear warm clothes in a cold climate, you give aggressive environments, give a protective coating for the structure. That's very important. Even cladding, like stone cladding, also helps in reducing. And we do waterproofing, box type waterproofing for the foundation to protect the structure from the soil contaminants and the dampness or water table variation. So same way, we have to protect the foundations, mainly important, and then superstructure from the environmental factors, temperature and humidity and dampness and the chemicals. We have to protect.
Right. So thank you. Thank you so much. I think we are at
Yeah.
the end of the talk. For all the participants, this talk is going to be there on our YouTube and Facebook channel. So if you can go back, you can hear it again in case you've missed something. Thank you so much, sir. It's been a really
Yeah.
enlightening talk. I think one aspect that every civil engineer has to take into consideration, especially these days when we're seeing the durability of the buildings being so low. In fact,
Yeah, correct.
lot of collapse and the engineer being blamed, and there's a lot of cases like that coming up in the recent times. Probably one of the aspects that is missing is how to ensure that the building is durable, and that has to come into the design element itself, in the design stage itself. Thank you so much.
Thank you, Shruti. Thanks to Task for giving me this opportunity to share and gain some knowledge on this service life design of the building. So thank you very much.
We'll keep coming back to you for more.
Yeah, definitely.
Thank you to NIT Warangal for collaborating with us. Thanks, Smart and Frest, for collaborating with us. We're coming up with other programs also for civil engineers. So stay tuned. Next Tuesday, 3 o'clock, we'll be back with another interesting talk on another practical aspect of civil engineering. So see you soon. See you then, and take care and goodbye.
Okay, bye.
Thank you, sir. Bye.